Hi Pre-Calc people, we are looking at 2.2a today. We're going to talk about power functions and relations. Okay, so here we go. Okay, power functions. Here, I'll put the Mr. T version over here, which is noteworthy, of course. Okay, pretty much what it says is any function f of x that can be written as some k x to the a, where, you know, this is important, that both these guys are not equal to 0, is a power function. That's a power function. It's x to some power times some constant. K is your constant variation. And a is the power. It's the power of the function, because it's what power is taking to. This reminds me of a little joke. X squared is talking to x cubed. X squared tells to x cubed, what religion do you believe in? X cubed says, I don't know what religion I am, but I definitely believe in a higher power. I'll let you guys sit on that one for a little bit. Okay. So, this right here says constant. You don't have to write this, guys. This is the big stuff. You don't have to write the joke either. So, the constant proportion, you say f of x, your function, varies as the blank power of x. And it is proportional to that eighth power of x. Okay? Next slide. Okay. Before we get going, I want to talk about direct versus inverse proportionality. Okay? You're going to be reading a story problem. You're going to say, Ms. Twilliger, I don't know how to set up this problem. So let's take a look at what direct means. Is that your f of x, this is for direct, equals your constant times x to some power. Okay, that's directly. Should I underline this in red? Inversely says that your function f of x varies inversely to your constant k. So that's k over x to some power. So whenever you hear direct, that means you're multiplying it by it. Inverse means you're going to put that guy on the bottom. Okay, so let's see where this might actually pop up. For direct, it says the area. Wait a second. Let's be consistent here, buddy. Direct says the area of a circle varies directly to the square of its radius. Okay. So my area of my circle, my A, varies directly. So I'm going to put my equals here. To the square of its radius. Okay. So that means my r squared I'm going to put right here. That's my square of my radius. I'm going to keep it on the top because it varies directly. And now this varies directly tells me that I can put my constant out in front. Now we all know area of a circle is pi r squared. This pi is our k. There's a constant to this guy. Okay? 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 Okay. Sorry. I had to go there, guys. Let's take a look at another one. This is good old physics. We have the force of gravity is inversely proportional to the distance from the object to the center of the earth. Bum, bum, bum. Okay. So my force of gravity is inversely proportional, so I'm going to put that outside with an equal sign. Is inversely proportional. So I know it's going to be a k. Now that k is going to be on top of something. And that's to the distance from the object to the center of the earth. So this tells me, since it's inversely proportional, I'm going to put my x to the n down here. Okay? I'm going to show you guys the real formula for that to see if we were close. Gravity is equal to your gravitational constant. You're supposed to be a big F, little g. Gravitational constant times your mass 1 times mass 2 all over your r squared. And your r is your distance between objects. And your g is constant. So we actually did it, guys. We figured this out by reading it. Okay. Now we're going to do something that's a little bit easier. State the power and constant of variation for the function f of x is cube root of x. And I threw this guy in here, 3 over x squared, and graph it. Okay. So let's take a look at this guy first. First thing I'm going to do is rewrite this. This is the same thing as what? X to the 1/4 power. Now, unlike before when we were dealing with the polynomials, you can have fractions, you can have negatives, you can have a lot of different things up there, guys. So, my constant of variation, my k, equals, what number's out in front here? Well, 1. So my k is 1. K is your constant of variation, your COV, if you will. Now, what's my power? Well, you just take a look up here. 1/4. Now let's take a look at this guy. Again, first thing I'm going to do is rewrite this. But now, does this vary directly or inversely? If you said inversely, give yourself a cookie. Because here we go. I'm going to rewrite this. Okay, that same thing as 3 times x to the negative 2. So first off, what's my COV? My k is 3. Right? What's my power? Well, my power is equal to negative 2. There you go, guys. That's all there is to it. Nothing too scary, nothing too scary. Alright, next slide. This one's kind of scary. The weight a board can support varies directly with the square of its thickness. A board is 4 feet long, 4 inches wide, and 2 inches thick, can support 200 pounds. How much weight could a board 8 feet long, 4 inches wide, and 4 inches thick support? Oh no, get out of here. I'm going to hear about that one tomorrow. Okay. So the weight a board can support varies directly. So I'm going to start off with my W equals, varies directly. I'm going to put a K in here, because I know that varies directly with the square of its thickness. So that means I'm going to say times because it varies directly. And then for square of its thickness, I'm going to use, what letter should I use for thickness, guys? I'm actually going to use H times H squared. Okay. Now, does it say anything about length and width, so long and wide? No, so I'm going to cross those guys out because we are not going to need this information. Not only that, it's the same between them anyways. Okay, so I'm crossing those out. So now what we got to do is find this constant. We have to find it. Don't say, oh, it's right there, it's K. No, 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 guys. So we have an example. When the board is 2 inches thick, it can support 200 pounds. Yellow. Why would I even have yellow there? We will go with orange. So we're going to take this 200 pounds and plug it in for our weight. Actually work better if I use glue. So we go 200 pounds equals, we don't know our constant yet, But we do know the height, the thickness was 2 inches. So I plug that in for my h. And what I end up getting is 200 equals 4 times k. Divide both sides by 4. And I get 25, 50, right? That's my constant. So I take this and I plug it into my original equation. So I end up with W equals 50 times h, which is thickness, squared. So it asked us how much weight could a board 4 inches thick support? Well, I plug that in for my thickness, right? And I end up, well, whatever 50 times 16 is, which is 800 pounds it can support. Okay? So again, first thing you do is you plug in what you know, solve for that k, put it back into the equation, plug in your new variable, bada boom, bada bing, you have your answer. Okay? One more thing I'm going to show you guys. Last slide. Monomial function. What is a monomial function? Good question. Monomial function. It's a function that can be written as this guy. But k is still your constant, and n is a positive integer. Okay? So n has to be greater than or equal to 0. If you want my Mr. Terwilliger's side note on this monomial function, is anything that's k times x to the n, and n has to be greater than or equal to 0. Okay? And you may say, well, it says here positive, but now it could just be f of x equals k, which means you're actually have 0 power. So this covers everything. Okay? K is still your constant. So pretty much is our power function where n is greater than or equal to 0. Guys, think about that. Here's an example. Be something like 5 times x to the third. Here's a non-example. Would be something like 5 times x to the negative 3. Or 5 times x to the n. Those are not examples. Okay? Not? Yes. Not? Yes. Alright. That's where we're going to end it, guys. Hope you enjoyed.